So I've got all the components pulled out of the laser, and I'm making this video for anybody who's following along and also as a reference for myself. But in the last video I made, I kind of pointed towards this switch mode power supply as being a potential issue for the G2J amplifier supply. And my suspicions were correct. There was some issues I found on the board, and we'll kind of talk a little bit about that. So without going into too much detail, like I said, this is the switch mode power supply. It charges the capacitor bank within the laser. It takes DC voltage in, kind of powers up some of these PWM drivers and the gate drivers for the MOSFETs that are on this board. And then also you have an AC line of 220 in that goes through a line filter, a fuse, a rectifier, and a capacitor, which give you a nice smooth sort of DC high voltage signal around 320 volts. That all gets fed through some, like I said, MOSFETs, some diodes, and a transformer, which charges the capacitors, like I said. And I should have done some further investigation. I did find one shorted out capacitor, and then I decided, you know, I didn't really want to pull all the MOSFETs, although I really should have checked the MOSFETs. It was a rookie mistake, and hindsight's always 20/20, because one of the MOSFETs here that come in after the DC voltage was bad. So I found a shorted MOSFET, and I did power the board for a little bit and got the unit kind of displaying correctly, but it was not charging the capacitor still. I let it run for another 15 minutes or so, just to see if everything would remain stable as far as booting up into the waiting screen, or I guess you could call it. It wasn't charging, but it was booted up as expected. And while that process happened, the shorted out MOSFET caused some overcurrent on this board here, and I popped a couple resistors. Luckily, I'm hoping that that is the only issue, but this board, just so you can kind of get an idea of what this is the DC voltage supply board for powering all the different components. DC voltage. It takes a 24 volt in and ends up kind of going through some transformers to step the voltage up to 40 volts. It also goes through some regulators and some other components to kind of step down the voltage, and you get ribbon cables that kind of come off and power different devices in the laser. So out of this board, you get 24 volts in, you get 40 volts out, you get 24 volts out, you get 12 volts out, and then off this little sideboard here, you get 5 volts, 1 amp regulated out. So you kind of have a whole slew of DC voltages coming out of this, which can power components. And like I said, I ended up popping a couple resistors on the back side. Luckily, I took plenty of photos of every component, so I do know the resistors that need to be replaced on here, and they're on order. And I also found that a MOSFET was fried here near the inlet. So likely I caused these issues because this board was functioning and didn't have any issues so long as the DC voltage was disconnected from this board, which I showed you in the previous video. I am fortunate because I did manage to get a pinout of all of these components here. So I did figure out what the expected DC voltages are out of this, and so my plan now is to take all these components and keep them out of the laser and benchtop test each one independently. So I'll put 220 main voltage in here. I'll obviously disconnect this, make sure just to confirm that this is functioning again. I did test it under voltage, and this is working just fine. I'll replace the MOSFETs, and I will first of all test this board, then eventually I'll hook it back up to here and confirm that all the PWM signals out of the PWM drivers are producing pulse widths, and that the MOSFETs, of course, after I replace them, they will all be good, and there will be no shorts there. And I've already checked again all the diodes. I've checked all the other capacitors on the board. I've checked shorts between the chips on here for the gate drivers. I've checked the windings on the transformer and the inductor over here, and everything seems, fingers crossed, to be fine so long as I replace the MOSFETs and do a bench test properly on this. Once I bench test this, and I will also bench test this with 24 volts DC in and confirm that voltage is coming out as expected, then I will combine these two boards again and power it using the ribbon cable here, just to confirm that everything is functioning there. And then I'll do some further tests again to confirm that everything for the switch mode power supply is working. I will check the output side here, which charges the capacitors, make sure that I'm getting an appropriate charge signal out of it, and then I will put things back in the laser. So again, hindsight 2020 on this. I should have checked the MOSFETs. I'm not an expert electrical engineer. I'm just the guy who knows a thing or two about electronics, and I know how to poke around. I know how to read data sheets. I know, what basic components do. I have an understanding of, rectification and half bridge, full bridge. I understand general knowledge about electronics and hardware. So I will again learn from my mistakes and bench test these before trying to put everything back together. Again, hopefully I haven't done any real damage. I don't think I have. Just a couple resistors have been blown. And so we'll go from there. The last thing I did note is that when I fried those resistors, I lifted the pads a little bit off of here. I checked the traces, everything's fine. So I've ordered up some silver conductive epoxy. And if you never heard of it before, I figured I'd mention it. There is a product that you can kind of epoxy down the leads back to the board, and it is conductive. So I'll just make sure to repair that little section there. I got all the resistors on order. I got all the MOSFETs on order. Some of them are no longer produced, but I did find suppliers for them. It's going to take about maybe 2 weeks before I can get back to the bench and test all these components. So stay tuned for an update, and if you have any input, comments, suggestions below, I'd appreciate it. Loic mentioned there might be an issue with this. I didn't think there was. I think it all again stems from this board, but I do appreciate Loic commenting on the previous video. It did help because I should have pulled all these MOSFETs. I should have checked the MOSFET at the inlet here before I even did anything. MOSFETs are definitely problem childs, especially in these high voltage situations where what likely ended up happening in this past life is a high voltage surge came in through this DC and ended up frying these MOSFETs here, shorting out this capacitor, and then the laser was no longer functioning. So there you go, there's your update. Sorry for the long-winded yapping session, but I figured I'd document this again for anybody who's interested. We'll see you on the next one.